Okay, today's lesson is lesson 9-1. I've given you a paper of notes. There's 2 pages, and I want you to glue those on the left side of page 72. Okay, so today's objectives is we're going to graph quadratic functions in the form of y is equal to ax squared, and then we're also going to graph quadratic functions of the form y is equal to ax squared plus c. Okay, so now we're going to go and take some notes. There's some blanks that we need to fill in as we read through these notes. And it says standard form of a quadratic function. A quadratic function is a function that can be written in the form, and right here on this line, it's standard form, and it's ax squared plus bx plus c. Okay, and that is where a, b, and c are real numbers and a is not equal to 0. Because now the a is the number that's in front of the x squared, b is a number in front of the x, and c is just the number alone. So if you had a 0 here, then this would no longer be a quadratic equation. It would be a linear equation. Okay? This form is called, and we talked about this before, standard form. S-T-A-N-D-A-R-D. Game descending order 2, 1, none. And then here they just gave you some examples of what standard form might look like in all the various ways. Okay, now the next one, it's a blank is the graph of a quadratic function, and the word is parabola. It's P-A-R-A-B-O-L-A. And that's what goes in that line. It's a little hard to fit in there, but it goes in here. It's a parabola. Right here is a parabola. This is a parabola. Right here is a parabola. These are all graphs of quadratic functions. The axis of symmetry is, and we're going to write this in, the fold or line that divides a parabola into 2 matching halves. Okay, and I'll read it again for you because I know my writing's pretty bad. The axis of symmetry is the fold or line that divides a parabola into 2 matching halves. Okay, I'm going to change my color because the next one's going to get mixed up with the red if I don't. The next line, it says A, and the word is vertex, is the highest or lowest point of a parabola, and I'm going to write it out here. A vertex, B-E-R-T-E-X, is the highest or lowest point of a parabola. The minimum of the parabola, we'll just kind of do this as a shortcut. The minimum of the parabola, P-A-R-A-B-O-L-A, opens upward. So the minimum is, we'll say instead of is, we'll put it of. The minimum of the parabola opens upward. It's a happy face. We'll put in parentheses, it's happy. Okay, and then this one at the bottom, I'm going to change colors so we don't get mixed up with this one. It's a maximum. Okay, so maximum, and here's the real definition, is the y-coordinate of the vertex of a parabola that opens downward. And this one we're going to say is a sad face. So last year someone told me they helped him remember minimum, maximum, because if you go to the store and you buy only the minimum amount with the minimum amount of money, you're happy. Like you buy something on sale, you're happy. And if you go to the store and you spend the maximum on something you wanted to buy, you spent all your money, you're sad. Okay, so minimum is happy and maximum is sad. So that might help you to remember those. Okay, so now we're going to go through and do a little bit of practice on this. We are going to go through and identify our parts of this graph. The vertex. The vertex is the highest or lowest point. Oh, sorry. So here is the highest point of this parabola. What's the order pair? 1, comma, up 2. So we went 1, comma 2. Remember, it's an order pair. Because it's a sad face, it's a maximum. Okay, and then over here, right here, is the lowest part of our parabola. That's our vertex. So we went over 1, 2, and then we went down 1, 2, 3, 4, negative 4. So that's our order pair for our vertex. And because this is a happy face, it's a minimum. So there's our maximum, this is our minimum. Okay, the next part we're going to do is we're going to compare two parabolas that are graphs. Okay, so it says that graphing y is equal to ax squared plus c. How is the graph of y is equal to 3x squared minus 2 different from the graph of y is equal to 3x squared? Compare the graphs. Okay, so what we're going to do is they gave us our x values right here, right there. Highlight it for us. This was our x values. I'm going to erase that so I can see the x again. This is our x values right here. All these are x values. And we're going to plug them in to our x value right here. Okay, so if I take, and I'm going to go ahead and do a little bit of work on the side so you can see what we're doing. This is the graph y is equal to 3x squared. They gave us our x values. They gave us 2, 1, 0, negative 1, and negative 2. And we're trying to find our y values. Okay, so we're going to go y is equal to 3 times 2 squared, which is 3 times 4, because 2 times 2 is 4, which is 12. Okay, so that's our y value. Our y is 12, and that's where that 12 came from. Then we do the same thing with the next one. With 1, we go y is equal to 3 times 1 squared, which is 3 times 1, which is 3. So our y is equal to 3. And then the next one, they did 0, and I'm just going to go ahead and do it. They already gave us the answer there, right? 0 times 0 is 0. 3 times 0 is 0. So our y is 0. That's how they got that 0. Then we're going to go negative 1. So y is equal to 3 times negative 1 squared, which is negative 1 times negative 1 is positive 1, and it's equal to 3. And then this one they already did for us, but we'll go ahead and prove that they're correct. We have 3 and we have negative 2 squared, which is negative 2 times negative 2 is positive 4. So 3 times 4 is 12. And that's how they got that 12. So now let's take our blue pen right here, and let's go ahead and graph it. We're looking at order pair of 2 and a 12. So we're going to go, well, I don't have 12 pairs. Let's start somewhere. Let's start at 0, 0. I have that on my graph. This is my first point. Oops, sorry. This is my first point. And then I'm going to go 1, 3. So I'm going to go over 1, up 3. And then, so I did this one right here, and I did that one. So now let's go down to -1. -1 up 3. Oh, sorry. -1 up 3 right here. And then it says -2 and 12. Well, 12 is going to be way up here. I'm just going to go off the chart. And then we're going to go +2 up 12. So we're going to go over +2 and then up 12 again off the chart. But here's my parabola. I'm going to connect those dots together. So we're going to go like this and like that. Okay, so there. I'm going to erase that one. Shouldn't be a double line, it should be a single line. I'm just not very good at using this pen and drawing. Okay, this one goes up here, and this one went up here. Okay, so that's my parabola. And it should be a little curved at the bottom. Okay, it should be a curve. Parabolas are curved. Okay, well, that's good enough. Okay, so that's the yellow one. Now we're going to take, and we are going to use the same y. So I'm going to shade this, same x, but now I have to find out the different y's. So I don't need, and I'm going to cross this out, I don't need this one anymore. I already did this. And now we're going to do the second one. So I'm going to erase my work over here. Erase that. And now I'm going to write the problem. We're going to fill in the blanks for, this is our equation now. Y is equal to, it's not negative y, just y is equal to 3x squared minus 2. And we are going to just use our same x values they gave us, but do the math and figure out what our y values are going to be. So they use 1, 0, 1, and 2, and -1 and -2. So again, we're just going to do the same thing. We're going to go 3 times 2 squared minus 2. So 2 times 2 is 4, times 4 minus 2. So 12 minus 2 equals 10. So it's going to be a 10 here. And I need to make some more space. Then the next x I'm going to use is 1. So now go 3 times 1 squared minus 2. So 1 times 1 is 1 minus 2. 3 minus 2, and we got 1. That's where they got the 1 here. And then we're going to do 0. So we've got 3 times 0 minus 2. Well, we have 0 minus 2, which is -2. So that's our -2. And then they did the same thing for the -1. So what do you notice? This one and that one. So if you have a +1, it's 1. A -1, it's also +1. Well, if that's the case, then this is 2. +2, I get 10. What do you think the -2 is going to get us? It's also going to get us 10. Let's make sure. We've got 3 times -2 squared. -2 times -2 is +4. 12 minus 2 is 10, and we did get 10. So when you square something, you end up getting the positive. So 0 and -2. This is our first order pair. So I'm going to go ahead, I'm going to erase the work over here, and I'm going to write my order pairs out so we can graph them. It's kind of hard to see with the graphs, so I'm going to try to break it down so you can see what they're doing. Okay, so we've got our order pair of -2, 10, and then we have, +2, 10, +1, 1, 0, -2, -1, and a 1, and -2, and a 10. Okay, so let's start 0 and -2 right here. And then we got 1 and a 1 right here. And then -1 and 1 right here. Oh, sorry. And then we have 2, and it's going to be 10. It's going to be again off the chart. And then 2, kind of off the chart. So now I'm going to graph it. Remember, it's more rounded at the bottom. We're going to take it up. And so here's our 2 graphs. The blue one was for this first one right here. And then the red one is what we found right here. Okay, and then at the bottom there it says the graph of y is equal to 3x squared minus 2 has the same shape as the graph of y is equal to 3x squared, but it shifts. What do we notice? This red one went what? Down 2 places. So it went down 2 units. Otherwise the graphs are the same. Okay, next part of this is I want you to try these on your own, and then once you finish it, then come back and we'll turn it on and see if you got the right answer. So pause it, and then we'll see if you get the right answer here. Okay, so you should have completed that section to do it yourself. And the first one, number 1, you should have got 4, 3 as your vertex, and it's a maximum. Letter B, so I guess that was A. B is -3, -3 is your vertex, and it's a minimum. So the first one was a maximum because it's sad, and the minimum because it's happy. And then when you go through on number 2, you're going to graph the red. The red was at 0, 0 was your vertex. And then I just chose 2 other numbers, and it doesn't matter what numbers you choose. I just chose 0, 1, and -1, and I graphed those. And then I did the same thing over here. I made a table, and I chose 0, 1, and -1 again, and then I did that, and my vertex for the blue line was 0, -4. And how did it change, or how did they compare? Shifts 4 units down. So from the red line, the blue line went 4 units down. So by that, having that -4 there, that made that parabola go down 4 units. And then it says for critical thinking, describe what positive and negative values of C do to the position of the vertex. And we saw from this one that from the red line, our vertex, this one went down because it was a -4, so negative numbers are downshifts. And if that would have been a +4, we'd expect it to have been up to the 4 above that original vertex. Okay, so that was 9-1. The notes were a little bit hard to write in, but I thought it would help us so you wouldn't have to write so much on your own. Anyways, I don't know if it did. Try your best.